In this video, we will explore the rule when multiplying like bases, add the exponents. We will begin by considering this example, a squared times a cubed. Remember the parts of an exponent expression. The base is the number that is being raised to the power. For instance, in the expression x squared, since x is being raised to an exponent, x is called the base. The 2, the number in the exponent, is called either the exponent or the power. When applying the rule when multiplying like bases, you have to identify the bases that are being multiplied together, and they must be the same. In this example, we have two bases that are being multiplied together. Because there's no sign between the a squared and the a cubed, the assumed operation is multiplication. So this is a squared times a cubed, and we're multiplying. The bases are a and a. Since those two bases are the same, they are like bases. So we've identified that we're multiplying like bases, so we can apply this rule. And this rule tells us that we will need to add the exponents. So let's do that. We keep the same base, so once we're multiplying these bases of a, the base will stay the same. We will simply add the exponents. The exponent of the first factor is 2, and the exponent of the second factor is 3. We add the exponents. This becomes a to the 2 plus 3 power. And of course 2 plus 3 is 5, so this is a to the 5th power. That's how the rule works. Let's explore why the rule actually works. So let's rework this example, a squared times a cubed. And let's do it in a different way, without applying this rule. If we didn't have this rule, we do know that a squared means a times a, and a cubed means a times a times a. So if I write out a squared as a times a, and a cubed as a times a times a, this is the expression I will get. A times a times a times a times a, which is simply 5 factors of a, which can be written as a to the 5th power. This is the nice thing about this and all of the rules of exponents. If you forget the rule of exponents itself, you can always go back to the definition of an exponent to rewrite the expression. You can rewrite a squared as a times a. That's what the definition of an exponent tells us. You can rewrite a cubed as a times a times a. Then you can figure out what the resulting expression should be. In this case, a to the 5th power. Let's consider the second example. In this example, we have x to the 5th times y squared times x times y squared. Again, there's no sign between each of these factors, but anytime that there is no sign between variables, we know that they're being multiplied. So we know right now that we are indeed multiplying. Now we have to identify whether or not we're multiplying like bases. The base here is x, and the base here is y. These two are not like bases, so we cannot apply this rule to the x to the 5th y squared. However, we can apply the commutative property of multiplication. Since within this expression, the operation that's happening is multiplication, we can change the order of the multiplication. We can change the order of the factors. Let's do that. Let's find the like bases. For instance, here's an x to the 5th factor, and here's an x factor. They are like bases. So let me group the x to the 5th with the x. Changing the order here, I brought this x to the 5th straight down so that it's still first, and then I advance this x up a little bit here in front of the y squared. Then I will multiply my y factors. So the first y factor is y squared, and the second factor is also y squared. Notice that I've taken my x's, and they're all represented down below, x to the fifth and x. Similarly, all of the y factors are represented down below, both y squareds. I've represented all of these factors down below using the commutative property of multiplication. Now I can apply this rule. When multiplying like bases, and here x to the fifth times x, I have like bases, I can add the exponents. Whenever a variable does not have an exponent, you can always give it an exponent of 1. Now I can apply the rule. You always keep the same base, and then you add the exponents. This will be 5 plus 1. I can apply the rule again with the y's. This is going to be y to the 2 plus 2. Simply add the exponents, keep the same base. 5 plus 1 is 6, so this is x to the 6th power. And 2 plus 2 is 4, so this is y to the 4th power. So this expression simplifies to x to the 6th times y to the 4th power.